And the initial devices will really just be pretty basic. It'll be about restoring functionality to people who've lost their connection between their brain and their body.
The human brain is an engineering marvel capable of processing massive volumes of data with lightning-fast speed and accuracy. For decades, scientists and engineers have attempted, with varied degrees of success, to recreate the brain's capacities in machines. This is because there are a lot of things computers can do better than humans, such as calculating square roots or obtaining a web page instantly. However, our beautiful brains still outperform computers when it comes to common sense, inspiration, and imagination. Artificial neural networks, ANN, inspired by the brain's structure, are the answer to making computers more human-like and assisting machines in reasoning more like humans. Join us today as we check out why big players like Elon Musk are involved in it, and could it be the future of humanity? But before we dive into anything, let's first understand what exactly are neural networks. This technology is inspired by biological neural networks. This computing system learns to execute multiple tasks by considering specific examples, usually without being programmed with task-specific rules. Neural networks are a deep learning functional unit inspired by the organization of the human brain. On the other hand, artificial neural networks are a functional unit of deep learning. For example, image recognition can be used to identify a cat image. By examining example photographs that have been manually labeled as cat or no cat, the computing systems may learn to detect images that contain cats. They can learn to identify the actual image by utilizing the results to identify cats in other photographs. They accomplish this with no prior knowledge of cats or their characteristics, such as their fur, tails, whiskers, and cat-like faces. With that in mind, why is Elon Musk, one of our generation's most ambitious man who makes reusable rockets, blankets the planet with Wi-Fi, and construct a network of tunnels beneath Los Angeles, so interested in neural networks that he made the company Neuralink, possibly his most intriguing venture ever? Neuralink is a firm founded in 2016 and is creating brain-machine interfaces, a cutting-edge technology that connects digital systems and the human brain. We're merely scratching the surface of what's out there since everything has been marked top secret up to this point. So, what did Elon Musk reveal for the first time in 3 years about the development of Neuralink? The short-term goal of Neuralink is to develop a direct cortical interface for uploading and downloading thoughts. It will eventually aid in implanting devices in paralyzed persons, allowing them to control electronics such as smartphones or computers. A sophisticated device implanted in the brain will enable a person to control any wireless device using only their thoughts. With nothing more than the power of thought. Wow, I mean it. Furthermore, Musk claims that 2 persons with such implants can communicate telepathically. It sounds like science fiction, but it's not. Since ancient times, humans have attempted to manipulate their brainwaves to solve ailments, and Musk is on his way to making it happen. After all, if he succeeds, it will mark a significant new step in the development of technology and humanity as a whole. Or will it be humanity's hacking? Mr. Musk's startup, Neuralink, revealed a small gadget with thousands of electrodes connected by fine threads at a presentation in San Francisco. Neuralink examines the flowing blood vessels in the cerebral cortex thickness independently and installs these stimulators. Yes, they can either read or send the signal. The device's operation is amazing. As a result, even with many Neuralink threads installed, the vasculature stays intact and the functioning of the afflicted portions of the cerebral cortex does not suffer. In contrast to the materials now employed in neurocomputer interfaces to construct prostheses and sensors that read brain signals, Neuralink will connect the human brain to the computer via thin polymer threads, effectively the device's major functional component. In contrast to the materials now employed in neurocomputer interfaces to construct prostheses and sensors that read brain signals, Neuralink will connect the human brain to the computer via thin polymer threads, effectively the device's major functional component. The ultra-thin threads used by Neuralink are constantly being developed. Neuralink has developed a device that works like a sewing machine to implant these threads and connect them to active neurons. These threads should be able to transmit massive volumes of data. Neuralink's ultra-thin threads will not hurt the human brain since they are movable and can adjust to changes in brain location. Neuralink is projected to perform somewhat better because the new polymer system employs up to 3,072 electrodes formed by an array of 92 threads. This means that this technology might be far more powerful, while yet being physically flexible enough to connect to the human brain. However, Neuralink threads, which will be thinner than human hair, will be far more difficult to implant in the brain than systems such as the Utah array. As a result, the second stage is to create a specialized neurosurgeon robot to implant Neuralink's ultra-thin threads into the brain automatically. A specific robot was built for this purpose, which uses a 24-micron needle to automatically implant a device capable of implanting 6 threads, 192 electrodes every minute. In fact, this robot surgery resembles a hybrid between a microscope and a sewing machine. The final stage is to create a unique microcircuit that can read, filter, and amplify information from the brain. It can now only transfer data via a wired connection, USB-C, but the eventual goal is establishing a wireless system. This wireless interface will be embodied in the N1 sensor by Neuralink, designed to be placed in the human body and wirelessly transmit data. 4 of these sensors will be implanted by Neuralink, 3 in motor areas and 1 in a somatosensory area. It will communicate with a tiny, wearable computer called Link, which is situated behind the ear and contains a battery. According to Neuralink president Max Hodak, it will be operated via an iPhone app. I also want to make an essential remark. Some specialists believe that more information is required to evaluate the technology. Electrodes inserted in the brain frequently produce the discharge of high-salt fluids. This can cause the electrode's substance to degrade. As a result, I anticipate that the next stage will be to modify the neurons in the brain, giving them photosensitivity at one wavelength and bioluminescence at another. The problem of electrode oxidation will be solved, and cortical activity can be monitored and stimulated very precisely by using a thin pellicle made from an array of photodetectors and emitters. Finally, nerve fibers will be able to be fused with silicon crystals, maybe using the recently disclosed protein sequences bound to mineral surfaces technology. Apart from the fact that Elon wants to give our brains a tech update with artificial neural networks, this tech also has a wide range of benefits and capabilities. One of their primary capabilities is their ability to learn from data and continuously improve their performance. Because of this versatility, they are particularly well suited for applications involving large amounts of data, such as image identification and natural language processing. Furthermore, they are not limited to certain domains. ANNs may tackle many problems, including natural language processing, NLP, speech recognition, and even medical diagnosis. As the field of ANNs advances, so do their power and potential. Furthermore, ANNs distinguish themselves by their ability to produce predictions that older approaches may find challenging. They excel in detecting intricate patterns in data, allowing them to make advanced predictions. For example, they can estimate ad-click likelihood based on historical user behavior and extra characteristics, or anticipate illness development based on a patient's medical history and other circumstances. However, ANNs are not without their difficulties. Training them can be difficult, requiring large amounts of data and time. Furthermore, they are vulnerable to data noise, which might lead to mistakes when the data is not clean. Their computational requirements, which need tremendous computing capacity for data processing and prediction, might also be a barrier. Furthermore, the opacity of ANNs, which are frequently referred to as black boxes, might make it difficult to understand their prediction mechanisms, complicating troubleshooting for incorrect predictions. Another major problem is the possibility of ANNs producing biased or unjust models. This is due to the fact that they learn from data that may be biased or unfair. As a result, it is critical to exercise caution when picking training data in order to avoid creating models that perpetuate bias or unfairness. So what does this mean for the future of humanity? Well, the future of artificial neural networks is really bright. ANNs are continuously growing, becoming more powerful and capable as they find applications in various industries. We should expect even bigger breakthroughs in their capacities as their development progresses. ANNs can play a critical role in disease diagnosis, drug discovery, and individualized treatment strategies in healthcare. Their application in self-driving automobiles, optimizing traffic flow, and improving air travel safety is a game-changer in transportation. ANNs have the ability to automate operations, improve quality control, and aid in the design of creative products in manufacturing. Their ability to foresee market trends, manage risks, and steer investment decisions holds enormous promise in the financial sector. Furthermore, by personalizing learning materials, providing valuable feedback, and evaluating tasks, ANNs can personalize educational experiences. The potential for ANNs to improve our lives spans multiple dimensions, offering healthier, safer, and more productive life. The prospects for future breakthroughs are limitless as these technologies evolve. We'll just have to wait and see how this plays